All right, little refresher on solving quadratics. A quadratic equation generically looks like this in standard form. Most students don't like it because it's nothing but letters. I'm going to put some numbers in there instead. It's going to be equal to 0 most of the time, and I got, like, say 2x squared plus 3x plus 5. Quadratic equations mean the biggest exponent you see is a square. Do you see how the x is being squared? Right? There's an x squared. Not an x cubed, not an x to the fourth, just x squared. There's three numbers that are going to help us. They're the a, b, and c, which messes with a lot of people's brains because a is always the number in front of x squared, b is always the number in front of x, and c is what's called the constant term. Why is it the constant term? Because it doesn't have a variable next to it. It doesn't vary. That number is always 5. So there's many ways to solve a quadratic. You should have learned that there's the quadratic formula, there's easy factoring, there's frowny face factoring, there's complete the square, there's the square root method. It was information overload back in Algebra 1. So we're going to just learn kind of the best times to do it. First, this is the quadratic formula. Is it on your yellow cheat sheet? Look now. I'm not going to let you use it if you don't cooperate with me, right? Cooperate with me, you can use it. But if we take a quiz next time, got to know it, right? Got to know it. According. Here's how the quadratic formula is going to work. First thing first, we have to have a quadratic equation, and it must be equal to 0 first. So I call it ready to run. Being ready to run means it's equal to 0. Is this guy ready to run? Yep. Do yourself a favor. Down the side, let's do A equals, B equals, C equals. This is a lifesaver. A lifesaver. A is always the number in front of x squared. So, even though we don't see a number there, I think we should know that there's a 1 in front of there. Are we okay with that? So A is 1. B is the number in front of x. Yes, the sign matters also. It is a minus 4. Are you cool with that? And C is the constant term, which is 3. Feel good, find an A, B, and C. Now, we substitute these homeboys into this formula. So a lot of people call this negative B. I wouldn't call it that. It's called the opposite of B. In our case, isn't B negative 4? What is the opposite of negative 4? Positive 4. So let's write. So you got to show all this work for me. There's the opposite of B. Then I do plus or minus. You need the big old honker radical for the square root of. And because we are advanced students, I feel we can do this next move either in our brain or in our calculator. Right? We can do a 2-for-1 special. We need to take B and square it. B is negative 4. What is a negative 4 squared turn out to be? Is it 16 or negative 16? It's always going to be a positive number. This guy right here will always be positive. And if you type it in wrong, it's going to give you a wrong answer. Putting negative 4 squared in a calculator is going to come back with negative 16 because you didn't put the negative in parentheses. Parentheses make a huge difference. Like negative 4 had to get squared, so that's why it has to go in parentheses. I say, don't even worry about the sign. You need to know that that's always coming positive, dude. Just put 4 squared in your calculator if you don't know what it is, right? Don't worry about the negative. Then we'll just copy the rest down. Minus 4. Use parentheses here. It'll save your brain from a bunch of crazy dots and stuff like that. So times A times C, which is 3. I wrote C down over here, but it's supposed to be a 3. And then see the radical symbols, got to cover it all up. All of it over 2 times A. That is another move that I think we can do in our brain. 2 times A is 1. What is 2 times 1? So I require that being shown. Are you down with that? Next thing, grab your calculator, and we're going to do this move right here, just the green crap. We are going to punch in the green thing, not the square root sign. We're not going to do it. Punch with me. It's going to be 16 minus 4. Use parentheses. It'll save your life because then you won't have any typing errors instead of the times button. Times 1 times 3. You see, I literally just typed in what I got right here. Hit equals, what you got? 4. So we're going to recopy everything down. This is 4 plus or minus square root of, and then we cleaned all of that stuff up there to be a 4 all over 2. You down with me? Now I'm going to treat you like you're taking an ACT, because someday you will most likely take an ACT. They use language that you're like, excuse me, what does this mean? This blue 4, what we just found, has a special name. It is called the discriminant. I'll say it again. It's called the discriminant. What's that thing called? The discriminant. If you've never heard what that is, it's hard to answer the question on the ACT about discriminants if you've never known what a discriminant is. So this is the discriminant. Hey, I love the number 4. I love them like 1, 9, 16, 25. What's so great about the number 4? It's a perfect square, right? What is the square root of 4, my friends? Well, there's one of them. 2 is one of them. Isn't it also a minus 2? That's why there's a plus or minus symbol in front of this, because you get 2 answers to it. So we're going to do this, 4 plus or minus 2 all over 2. Sorry for the bad handwriting. This cleaned up. Square root of 4 was nice. And now we have to follow the order of operations. We have to do what's in a group first. This fraction bar separates us into 2 groups. You know the names of the 2 groups. The top one's called the numerator. The bottom one's called the denominator. We have to do 4 plus 2. Help me. What's 4 plus 2? 6 over 2. Or 4 minus 2 is 2 over 2. Guys, that's why it's called a plus or minus. I did the plus over here, or I did the minus over here. And then obviously we can clean these up. 6 over 2 is really 3, and 2 over 2 is really 1. There are our solutions. Yes, we could have done that by factoring if we wanted to. There's many ways to solve the quadratic. We are just doing the first few by the quadratic formula. Quadratic formula works every time. Any type of quadratic can be solved with the quadratic formula. How do you use it again? First, it's got to be ready to run. It's got to be equal to 0. Is this guy ready to run? Do your brain a favor and figure out who A, B, and C are. Check them with mine. How do you feel about those? Let's now substitute them in. Let me show you the way I've been doing this since 1993, which was a long time ago. Every single time, even though I'm 41 years old today in 2021 when this video is being recorded, that I still do the quadratic formula the same way. I say it out loud, well, kind of in my brain, not really out loud, when I write it down. The first thing that my brain says is opposite of B, but I write down 5. Are you with me on that? I say opposite of B. Then I say plus or minus the square root of. Then my brain says B squared. But I'm not going to write down B squared. I'm going to write down what number? 25. Minus 4 times A times C all over 2 times A. So I literally say the quadratic formula out loud in my brain, like my conscience says it, but when I write down is the numbers that go in those places. That's how you memorize something. You do it over and over and over again. Let's find this. Anybody remember what it's called? Starts with a D. It's called the discriminant. Punch it in. Punch it in. So 5 plus or minus, big old honker, all over 2. What did we get for a discriminant? Got a vote of 9. You guys okay with 9? Make sure you can get it. Do you like 9 for a discriminant? When it's underneath a square root, do you like the number 9? It's a perfect square, so it's going to come out real nice. What is the square root of 9, baby? You ready for a oopsie? I've been grading for a long time. Here's a oopsie. What's wrong with that? Yeah, you don't need the square root. That's a oops. You know, oops, my bad. The square root of 9 is not the square root of 3. It's just 3. Cool? So just 3. Then we'll do the plus. What's 5 plus 3? 8. Put him over 2. Or 5 minus 3 is 2 over 2, and 4 or 1. I won't lie. If you can skip this step right here that I'm highlighting down here in green, I'm cool with that. If you can go, okay, 5 plus 3 is 8 divided by 2, and you go straight to the 4, and you go straight to the 1, I'm down with that, right? But all of this other stuff is required to be shown. Hey, both of those came out real nice. You know why? Because the discriminant was a perfect square. And that means you could have factored those. Anytime you do the quadratic formula and the discriminant is a perfect square, you could have actually factored those. We'll show you that later when we refresh our brains on factoring. But let's try the next one. Uh-oh, is he ready to run? He's got to be equal to 0 first. Is he ready to run? Nope. So we got to move stuff over. It doesn't matter if you move the x squared over or these over. What would you rather have? A positive x squared or a negative x squared? Most people really like it when it's positive, so I'm going to keep the 1x squared right here. Then once you have to subtract Mr. X, and subtract Mr. 2, got to put the equal 0. I know most of you are getting used to me. So far I like what I've seen, but I'm picky. If you lose the equal 0, it's wrong. Got to have the equal 0 part. Starts an equation, it's going to remain an equation the whole time until we solve for x. Find you some ABCs. Check them with your neighbor. Uh-oh, where did it go? Dude, that's not good. A is 1. What's B? -1. What's C? -2. Now, it could possibly be, if you move this to the other side, A could be -1, B could be +1, and C could be +2. It's all going to work out, right? But if we moved this over here instead, it would still work if all of these numbers were complete opposites. So, weirdo. Sub it in. I'll say it. Opposite of B, you put 1. Plus or minus, square root of B squared. What is B squared? 1 minus 4 times A times C all over 2 times A. Rock and roll. Find the discriminants. Punch this into your calculator. So that's why using parentheses is going to save us for all those dang minuses. So it's 1, then you use the subtraction sign because that's what this is. 4, then parenthesis, 1, parenthesis. You got to use your negative symbol on that too. You can't use a subtraction symbol. And did you get this for a discriminant? 9. So nice. Could we factor this if we wanted to? You can only factor them if the discriminant is a perfect square. Could we have factored this? Yes. So 1 plus or minus shui over 2. See if you can get to your 2 answers. 2 answers. 1 plus 3 is 4. It's over 2. 1 minus 3 is -2. It's over 2. 2 or -1 is what I got. I hope it's refreshing to memory, right? You should have seen this before. I definitely know. I listened to how many people said it last year. Oh, I'm not doing any of this homework. I'm just copying the answers off the answer key because they post them online. You know, I've given up. Shot yourself in the foot. Now it's time to redeem yourself if you were that person. Cool? All right, here's what I need you to do at home. Pause the video. Try number 4. Give it a shot. So we did quadratic formula here. Got a discriminant of 36. That cleans up to be 6, and then we get our 2 answers. Hey, quadratic formula works every time. If you want to solve a quadratic equation, it works every time. Got to get it ready to run. Got to know who A, B, and C are. Sometimes there's zeros, right? But it works every time. The bad thing is, it's a lot of work. It's a lot of work. Sometimes there's a faster way to solve some quadratics. One of those ways, oh, we got another one? Sorry, good, because I thought, let's do one more. Let's do number 5. I thought we were done. We have 2 more. They're going to be nasty. Would you agree all 4 of those came out real nice because the discriminant was a perfect square every time? Let's see what happens when the discriminant is not a perfect square. So let's get this guy ready to run. All right, getting him equal to 0. Sorry, everybody. I thought we were done with the quadratic formula. All right, we had to subtract the 5 over. Now we got a new A value. We've had A, B, and 1 every time, so it's different. A is 2, B is 6, C -5. We're down with that. Sub them in to the quadratic formula. B squared is 36 minus 4 times A times C. Here's big boo-boo number 1. We accidentally just put a 2 down here every time. It is not a 2. It's 2 times A, right? But A so often for us is 1. We need a 4 down here. Isn't it 2 times this 2 right here? Are you okay with why that's a 4? All right? Then find the discriminant. I think it's going to be 16. Is it 16? Or did I do my math wrong? 20, 40. Oh, it's negative, isn't it? Did you get? What do you get? No, it's positive. Plus 40. 76, is that what you got? Sorry. I'm trying to do it mentally. It's 76. Hey, we've only had a few days of practice of putting our perfect squares down. Is 76 a perfect square? Is he on the list that you make? So we're leaving it like this. Yes, we can simplify that radical. I don't want to go down that road today. I just want to leave it like this. So you might see on an answer key that I simplified the radical. This is it. Leave it like that. Doesn't come out nice. It's nasty town. Cool? That's the answer. As weird as it is, right? You know, that's what happens on the ACT. It's multiple choice. You see all these weird answers. It's like, whoa, what is this? There's our answer. You know, it's weird. In Algebra 2, we'll learn more about what these do, right? Yes, question. So earlier, before I realized we had more problems, I was talking about maybe there's a faster way instead of the quadratic formula. But hey, it works every time. If you're ever in a pinch and you need to solve a quadratic, that quadratic formula works every time. But I think when we got good number sense, which we're working on, right? Some of us have better number sense than others. When we have good number sense, factoring, especially easy factoring, is way faster. When the numbers are small. When you get huge numbers in here, I'd rather use the quadratic formula also, right? But when the numbers are small, like let me ask you this. Look at these. Let's do A, B, and C. What's A? You don't need to write them down, but you can if you want to. What's A? 1. There's the secret to easy factoring. To easy factor, the A value has to be 1. Otherwise, we do something called frowny face factoring. If you didn't go to Hayes High last year, I just made those terms up. I call them easy factoring because it doesn't take a lot of work. I call it frowny face factoring for 2 reasons. 1, it takes a lot of work, and 2, we'll literally draw a frowny face. I'll show you that later. But easy factoring is when the A value is 1. Here's the thing, though. It doesn't always work because you have to be able to find 2 numbers that multiply together to be C. Who's C? Is it 1, 10, or 9? Who's C? You have to find 2 numbers that multiply together to be 9. Let's talk right now. 9 is a pretty small number, right? You know, it's like if that was like 875, whoa, it's like that's a big number. But 9, there's not too many numbers that multiply together to be 9. Let's go through them. 1 and 9. Does 2 go into 9 evenly? Nope. 3 go into 9 evenly? 3 and 3, right? And that's it, right? It's like you go again, and it's like, okay, it's 9 and 1. Well, you already said that, 1 and 9, right? There's not too many numbers on the list. I need to find 2 numbers that multiply together to be 9, but at the same time add together to be 10. Now, we might have got that already from what I said out loud, but before we get going too fast, here's the real secret to making this work fast for us. When you look at this green number, what those 2 numbers have to multiply together to be, you got to look at their signs, right? We're always going to pick 2 numbers. And here's the thing about those 2 numbers. The 2 numbers that you pick, their signs could either both be positive, right? Couldn't you pick a positive and a positive? Or they could both be negative, like a negative and a negative. Or like one of them's positive and one of them's negative. You with me on that? So I need to find 2 numbers that multiply together to be 9. Let's talk about those 3 options. Could you find 2 positives? Is it possible for 2 positives to multiply together to be positive 9? Yes. Is it possible for 2 negatives to multiply together to be positive 9? Is negative times negative turn out to be positive? Right? Is it possible for one of them to be negative and one of them to be positive? It is impossible for a positive and a negative to ever multiply together to be 9. You with me on that? So I now know that the 2 numbers I find are either both positive or both negative. How do I figure it out? It's about they add together to be. Can 2 negatives ever add together to be positive 10? They cannot. So who are our 2 positive numbers that multiply together to be 9 and add together to be 10? If you need to make a list, this is the list we just made a second ago. 1 and 9 multiplied together to be 9. 3 and 3 multiplied together to be 9. Do any of those add up to be 10? These do. I call these our bingo numbers. Bingo! Right? That answers our question. 1 and 9 multiply together to be 9 and add together to be 10. The reason why I call it easy factoring is because now we just go straight to groups. We're going to say, all right, this group is going to always, whatever letter they're using, it's going to have an X And since it's a positive 1, we'll put a plus 1. Got to have the parentheses around it. And then the other group is going to be x plus 9. Why is it a plus 9? Because it's a positive 9 that we chose. Here's the thing that makes me different than a lot of math teachers. You got to have equals 0. If you don't have equals 0, I'm going to take off points. And here's what we just did. It's amazing. I know we're still new at all of this, but this thing right here, boom, and this thing right here are the exact same thing, except I just unfoiled it. Remember foil, right? First outside, inside, last. I just unfoiled this guy. If I was to foil this out, first term times each other is x squared, outside 9x, inside 1x, add those together, there's your 10x, and the last term times each other is 9. I just unfoiled it. But why does it make it so easy to solve? Is because now, don't do this, don't scratch it out, but now, would you believe all the x squareds are gone? There are no x squareds. Right? Up here, we had x squareds also, but they also had x's in it. That's a giant mess. Boo! Those suck. We cannot solve very well for x unless there's no x squareds. So it's called the zero product property. I got a green group and I got a blue group, right? If two things multiply together to be 0, one of these groups has to turn out to be 0 to make that a true statement. What value of x makes the green group 0? If x was? What plus 1 gives me 0? Negative 1. There's one of our solutions right there. X could equal negative 1. That makes the green group turn out to be 0. What makes the blue group turn out to be 0? What plus 9 gives you negative 9 back? Sorry, what plus 9 gives you 0 back? I said it wrong. What plus 9 gives you 0 back? Negative 9. There are the two answers. Done, dog. Done. I want to show you something. Don't write this down at all. Opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 10 plus or minus the square root of 100 minus 36 is 64 all over 2. 64 is a nice, neat, perfect square all over 2. What's negative 10 plus? Well, it's negative 2 over 2. What's negative 10 minus 8? It's negative 18 all over 2. Do you get negative 1 or negative 9 back for your solutions? It both works. This, when you get good at it, is so much faster. It's like riding a bike. The first few times was pretty difficult when you took the training wheels off. But once you get good at riding a bike, it's a piece of cake. You just keep riding it. Like, well, why did I fall down so many times? Because I didn't learn my balance. Let's easy factor this. How do I know I'm easy factoring? A value has to be how much? 1. So find two numbers that multiply together to be 10. Let's talk about their signs right now. Both positive, both negative, one negative. One of those is out. Both positive, both negative, one negative. One of those is out. Which one's out? One negative. So they're either both positive or both negative. This sign tells you what they're supposed to be. If that's a minus, they're both negative. If that's a plus, they're both positive, right? So you need two positive numbers that multiply together to be 10 and together to be 7. Yes? 2 and 5, right? 5 and 2, 2 and 5. What is amazing to me is how many students think backwards, and there's nothing wrong with that. But if I asked you to start counting, would you go 1, 2, 3, 4? Wouldn't you start from 1? You know, so I do my multiples of 10 like this: 1 and 10, 2 and 5, 3 doesn't go into it, 4 doesn't go in. I start counting 1, 2, 3, 4, 5, right? So 2 and 5, but I ain't mad if you have 5 and 2. Same thing, right? Same thing. But if I ask you to find two numbers that multiply together to be 36 and add together to be 14, you kind of want to go through a sequence, right? 1 and 36, 2 and 18, 3 and 12, 4 and 9. You know, it's like there's a sequence to go through, and it makes things logical in my eyes. So 2 and 5, easy factor, no work required. Throw them in the groups. Don't forget to equal 0. This looked like it blew a lot of y'all's minds, though. So we've got to find what value of x makes this group 0. What plus 2 gives me 0? If x was negative 2. Figure out what makes the other group 0. Negative 5. If you're asking yourself, isn't it always going to be the opposite of these two numbers? The answer will be yes if we're easy factoring, but not if we're frowny face factoring, right? So if you're easy factoring, I get you, but We ain't done yet. Why can I easy factor this one? What's the one rule to easy factor? A has to be 1. So let's find two numbers that multiply together to be 36 and add together to be negative 20. Holy crap, let's talk signs. 36, it's positive. Either they're both positive, both negative, or one's negative. One of those isn't going to work. Which one's not going to work? Signs is all I care about. Can two positive numbers multiply together to be 36? Yes. Can two negative numbers multiply together to be positive 36? Can a positive number and a negative number multiply together to be negative 36? Excuse me, positive 36. So the two numbers I have to find, their signs are the same. Should they both be positive or both be negative? They both have to be negative, right? So let's go through. I want to make a list. 1 and 36, but they're both negative. Do those add up to be negative 20? So I'm done with those. 2 and 18, both of them negative. Do they add up to be negative 20? Bingo, right? There's no excuse that says I can't find the two numbers. All you have to do, grab a calculator if you need to, and start writing a list of multiples of 36, figure out the signs, right, both negative, and then you'll find it. Now, if you can't find it, it means you can't factor it. So, but this one, we found it. X minus 2, boom. X minus 18, boom, equals 0. What value of x makes the first guy true? If x is not negative 2, it's got to be positive 2, right? Because negative 2 is 4. It's okay. Just sign there. Happy. 18. There's our two answers. Holy cow, what a lot of craziness. Let's try 10. I should have said also, anytime you want to factor, it's got to be equal to 0. Also, you got to get it ready to run. This is run. A value 1, though, now we can easy factor. See if you can find, I'll help you get started, two numbers that multiply together to be negative 6. Signs, both positive, both negative, or one negative. Tell me about them. If they have to multiply together to be a negative 6, one's negative, right? One's negative. See if you can find those two numbers. Please pause the video. Get that done. Start over. These are all the multiples of negative 6. Up here, any of these add up to be 1, right? They got to add together to be 1. Does that work? Nope. Down here, 2 and negative 3. They multiply together to be negative 6. Do they add up to be 1? They add up to be negative 1. Does negative 2 and positive 3 add together to be 1? So bingo. Set up your two groups. Set up your two groups. It's easy factoring. Negative 2 and positive 3 add together to be 1. X minus 2, x plus 3 equals 0. Time to get out of here. So what could x equal? X could equal 2 or negative 3. Easy factoring. Watch this though. X squared plus 7x plus 11 equals 0. Two numbers that multiply together to be 11. 1 and 11. Do they add together to be 7? So factoring is not possible on this one. Could you solve this though? Could you solve for x? And what would you use? What's it called? Quadratic formula. And you're going to get nasty answers. Just like that last one we did. Didn't we get a nasty answer? It had a weird radical in it, square root of 72 or whatever. It's going to be weird. But when they come out nice, they could factor. Whew! All right. Where was our answer's up here? Sorry, I didn't finish it. My bad. Our answer is 2 or negative 3. Yes, in that case. All right. I know our brains are, wow. Algebra is boring, right? Isn't geometry way more interesting? You know, but algebra is boring. But now it's time for the last bit, frowny face factoring. If you need help, number 1, I've typed out a list of instructions of what you got to do. So that's nice. In life, there's instructions sometimes. Sometimes you just get them from a YouTube video, right? But you look something up. Here's some instructions. Let's see if we can follow them. First of all, tell me, it's got to be ready to run. Is it ready to run? Is it equal to 0? That's step one. Here's the bad part. Why can't we easy factor it? Why can't we do the thing that we just did that was so easy? The a value is not 1. It is an 8 this time. So I made up the name frowny face factor for 2 reasons. 1, this sucks because it's a lot of work. 2, I literally want you to put this frowny face. Please do this. Meow, frowny face right here. You know why we're doing that? Got to multiply those 2 numbers together. You got to take a times b. It's 8, and here's 3. So watch it. Then put they multiply together to be right here. All right. So if you get the sign wrong, that process, you're not going to get some numbers. Make sure correctly first. Cool. So, and 2 numbers that multiply together. 24. Let's right now. What's positive? They multiply together negative. Positive. But together to be 2. So let's do it. 24. 2. 2 and what? 2. One of them's negative. If you need, you can find the numbers, but I will always show you, if you can't find the numbers, you can always list 3 go in the 4. Yes, it does. One of them's negative. Do those add up to be? And how about 4? 4 goes into 24. How many times? Are we going to do this way? Even if you can't find the numbers, list through every possibility. Here's our bingo. Right? Now for the fun part. If we put them in groups, it would be called easy factoring. It's not. It's frowny face. So here's a write it as 4 terms equal to 0. Who's the first term? Leadoff man. I'm a baseball guy. Sorry. This is our leadoff man. 8x squared leads off. 8x squared leads off. 2 come next with a letter next to it. One of them's negative. Start with -1. It works out so much nicer. Don't have one of these guys. I'm going to put a -4x and a, see how I put these 2 dudes next with an x because you trust me. And we need our caboose, right? Our caboose guy right here, the minus. And of course, we need the e. So we wrote it as all we did. Split him up. I got it wrong. And split them up. If I combine like terms right here is -4x, actually 2x. So I just split them up. Why? Because which is double group. Boom. Last 2 guys a group. Call that group. I'm going to bring back 2 letters to mind. Hey, we're going to GCF. This group, there's 4. The greatest common factor, meaning the and this it also. You take the smallest amount of x you see. There's an x squared and there's an x to the first. What's the smallest amount? It's just an x, right? So we have undistributed. That's what GCF is. Do the reverse distributive property for x. What do you got? What in here now? Division. What's 8 divided by 4? 2. X squared divided by x is just plain Jane x, right? There's 2 x's here. There's 1 x here. It's plain Jane. Here's where a lot of happens best. 4x divided by in here. This guy has to have terms in it. Divided by 4 is 1. X divided by x. You say cancel is what happens. So slice is right here. Between a 6 and 3, I know there's negative there. What is the GCF between those two bad boys? 3. Then this has x's. Does this guy have x's with him? So you can't pull an x out. It's not a common factor. Only a 3. And if you were trained right, whatever the heck group this is, this has to be the same group if you're doing it right. If you do 6x divided by 3, do you get 2x back? Then the minus comes down. 3 divided by 3, isn't that a 1 in that case? So this is what's called the common group. That has to happen. The first time you got a 2x minus 1, the second time you get a 2x minus 1. If you're not getting that, you're not doing it right. I will help you find your mistakes. Right? And then the last move is to regroup. It doesn't matter what order you do. This was the GCF I took out the first time, and this was the GCF I took out the second time. Weren't those the GCFs? Make them one group right here. 4x plus 3. Then the common group goes next to it. Boom. 2x minus 1 equals 0. Man, all of that work right there. All of that work. Now we got to use the zero product property. I'm going to go off to the side. Just watch this. Show you a trick for a second. 4x plus 3 is what this group is. Sorry for the bad penmanship. 4x plus 3. I need to know what makes him equal 0. Watch. Just watch. Just watch. Tell me what you would do to solve this for x. What's your first move? Subtract 3, right? So you get 4x equals negative. Then what would you do to solve for x? Divide by 4. I hope your math teacher last year taught you a trick called opposite of this guy over that guy. It was a 3, right? Right here was the opposite of that guy. Negative 3 over that guy. If I did this 20 more times with different expressions, you're always going to have to move this thing over, right? And how do you do it? With the opposite of it, and then divide by this guy. So x could possibly be negative 3/4. Or, let's see if we can do it on this one. Opposite of this guy. This is a minus 1. Who's the opposite of that guy? 1 over 2. There's your solutions right there. That is not an easy thing. That is a complicated process. That is why I call it frowny face factoring. Number 1, it sucks. You personally would probably go, when you have to do it. You would frown. 2, I like it because we put this frowny face thing. Let's do one more before. It's got to be equal to 0 first. It is. Can't easy factor because A is not 1. Put the frowny face and multiply those two homeboys together. What's 3 times negative 5? Negative 15. Our job is to find two numbers that multiply together to be negative 15. Think about their signs. And also add together to be negative 2. Find those two numbers with your neighbor. If you need to make a list, great. I don't require you to make a list. If you're stuck, I'm going to make you make a list. Right? So there's no shame in making a list. So we've decided that a 3 and a 5 are going to be involved. But remember, one of these had to be negative. Which one of these is going to have to be negative for them to add up to be negative 2? The 5. There's our bingo numbers right there. 3 and negative 5. Let's go and split them into 4 terms. Lead off man, 3n squared. Then, which one of these would you rather put next, the 3 or the negative 5? Put the negative one next. With the n next to it, that kind of gets missed. Then we'll put a plus 3n. Remember, you got to put your letters. Then put your caboose, which is the negative 5. Don't forget the equal 0 part. So we just split it into 4 terms, right? Equal 0. Double group. First 2 homeboys become a group. Last 2 homeboys become a group. Coop. First one, take the GCF out of this group. What's your question? Let's keep rolling. What's the GCF between these? 3 and a 5. It's 1, right? There's always a numerical GCF, but I know why you said n, right? So we're going to take out a 1. and you don't have to write it down. So each of these have n's with them. Take out the smallest amount you see, n or n squared. What do you want? N. Then times the quantity of, this is going to turn out to be 3 divided by 1 is 3. N squared divided by n is n. It's the reverse distributive property. You're like undistributing this. You're dividing. Minus comes down. What's 5 divided by 1? 5. N divided by n. Divide out to be 1. Now here's why I said you need to think of it as a 1. Because on the next one, people go, what's the GCF? And they say there is none. There's not a, between a 3 and a 5, there's not one. Between an n, this doesn't have an n, so they just leave it empty. There's always a GCF. Who is the GCF between a 3 and a 5? It's how much? It's 1. So you must factor out a 1. You have to take that out. That's tricky. And what you get, would you believe we're supposed to get a 3n minus 5 back? Like whatever this group is, I'm supposed to get this group again. Well, what's 3n divided by 1? It's 3n. And what's minus 5 divided by 1? It's minus 5. Same group back. But what happens to the best of us is we didn't take the 1 out. And when you regroup, you always have to get 2 dudes times 2 dudes. First one, make the GCFs a group of their own. The GCFs are what I have in red. What would you like for the group of the GCFs? N plus 1. And then the common group is the green group. Isn't that your 3n minus 5? Didn't switch to green, but still, 3n minus 5. And then you use the zero product property. What value of n makes this 0? That's plain Jane McGee, because the number in front of n is 1. What value of n makes this 0 if n is negative 1? What value of n makes this 0? Opposite of this guy over that guy. What do you want? Opposite of this guy over that guy. What do you want? Positive 5 over not a negative 3. Don't do the opposite again. You only do it once. The opposite of this guy over this guy. Right? So the reason why you're doing 3n minus 5 equals 0, wouldn't you add 5 over here and then divide by a positive 3 in that case? Bro, I went through that real fast. Please let me know if you have questions.